Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. For this video, I'm taking a look at something a little different. It's a question that came up from a fellow student of mine actually in the Masters of Teaching program. We were talking today and he mentioned a question that one of his tutoring students had encountered as they were sitting a scholarship exam for a certain kind of private school in Sydney. I won't say which school because I don't want to kind of jeopardize their examination process. But the question was really interesting. So my fellow student was kind of looking for a bit of help in how to tackle this question, particularly given it's aimed at Year 6 students. So any approach needs to be fairly simple in terms of not using particularly advanced mathematics. It needs to be something that you could feasibly expect a Year 6 student to be able to work out under exam conditions. So what I'll do is I'll talk through the question. I don't actually have a screenshot of it, but I can talk through what the question is requiring of the student. And then what I'll do is I'll run through an approach that I think you could probably expect a year 6 student, or be a fairly talented one, should be able to kind of have a crack at doing this technique. So the basic context of the question is it's about hexagons, and what happens is you continue to enlarge a shape that's made up of hexagons, and we're kind of focused on the number of unique edges that will be involved in this shape. So we start, I'll turn over to kind of draw up what we're dealing with, but we start with the most basic of hexagons. So if I just draw up a hexagon here, so one single hexagon will have 1, 2, 3, 4, 5, 6 unique edges by definition. So for n is equal to 1, in this case, the number of unique edges is 6. Now, as we'll see, it's going to be helpful in terms of looking for a pattern to think about how does the number of unique edges increase, and then how does that increase. And so for the first item, it's not really relevant. We don't really have an increase because it's the first item, but we'll start to fill out this table, and the whole idea, at least of the approach I'm going to use, is to see is there a pattern that we can take advantage of. So now the second expansion, and I might use a different color, maybe I'll use black, is what we do is we start adding on hexagons to this shape. So here in this first expansion, we just add on 3 to kind of create this shape that's ultimately made up of 4 hexagons, being the first hexagon we started with and then the extra 3. And now what I'll do, and this is just a kind of fairly manual brute force approach, is I'm just going to manually count the number of edges. And this is something that a Year 6 primary school student could do. There's no kind of fancy formulas here, it's just basic brute force. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So with that one expansion, we get up to 19 unique edges. And now we can note that that's an increase of 13, but there's no increase in the increase yet, so that's still not applicable. And now what we do, now the kind of pattern of this question is we continue to add an extra layer of hexagons. So each time the shape expands, the expansion involves completely surrounding the shape with a new layer of hexagons. And ultimately this question is asking the student to say how many unique edges would there be when you get to the 20th expansion. And as you can imagine, you probably don't want to actually manually draw up 20 expansions. I'd definitely run out of space here in this paper, but it would just take far too long. What we want to hope is that if we do it for a few expansions, if we can notice a pattern, we can then use that pattern to fill out the table and get to the number we're after. So that's what we'll do. Let's do the next expansion. Maybe I'll use red this time. So we'll just keep drawing hexagons around what we've already got. Alright, so there's our extra layer of hexagons. Again, I'm going to continue counting. Now I don't need to count everything again because we know we've currently got 19 unique edges. So I'll start the count from 19. So we've got 19, 20, 21, 22, 23, 24, 25, 26. 54, 55. So we've got 55 unique edges now. So I'll just note that down. 55 unique edges. What is that as an increase? I might just get my calculator to make sure I don't mess this up. 55 minus 19 is 36. So that's an increase of 36. And to get from 13 to 36, you've essentially added 23. So the increase in our increases was 23. All right, so now let's keep going. There's no obvious patterns appearing yet. So let's go to our fourth expansion. So I might come back to blue and let's just draw this up. So naturally, with every expansion, the number of hexagons that we have to add grows. So you can kind of see pretty quickly why you wouldn't want to have to end up drawing all 20 expansions. You want to hope that you notice a pattern before that point. And I think this is why this question is really interesting, particularly being aimed at Year 6 students. You're kind of testing their basic understanding of hexagons, I guess, so that they know it's got 6 sides. But then beyond that, it's really just how good are they at pattern recognition. And, you know, it'll take quite a good student, I think, to first of all, you know, think to do what I'm doing, which is to draw up what the question involves, and then to just, I guess, have the ability to structure their thinking to see, you know, can I find a pattern? So again, I don't need to count everything. I'm going to start from 55 and then add on the extra ones. So 55, 56. 108, 109. So let's note that down. We've got 109 unique edges. If I look at what's the increase, 109 minus 55, so that's an increase of 54. And how is that increase increased? Well, 54 minus 36, that's an increase on the increase of 18. Okay, still no patterns leaping out. Let's keep going. Definitely, this is a brute force method that I'm using. It's not pretty, it's not elegant, but I think it is realistic that a Year 6 student might have a crack at doing this. So let's go at the next expansion. I'll go back to black. So hopefully I don't run out of space here. Alright, so there's all my hexagons. As we see, it's growing at an ever-increasing rate. So we're starting at 109, so 110, 111, 112. 180, 181. Alright, so we'll write 181. The hope would be that we don't have to keep going too much longer before we see our pattern. 181 minus 109, that's an increase of 72. 72 minus 54 is 18. Alright, and now the potential pattern emerges because we see we've had two expansions where the increase on the increase has been 18. Now if we can do one more expansion and it's 18 again, well that's enough for a pattern. And you could then say, hey, I think the increase in the increase, at least from 4 onwards, could be 18. So then I can start to fill this table in reverse. I'll make all this 18. I can then work out my increases and therefore work out my unique edges without having to keep drawing. So the hope is, at least a student working through this process in the exam, at this point they're going to hope, okay, let's do one more expansion. Do we get 18? If so, you know, we're onto something here. So let's do this and hope that it's the last one we have to do. So maybe I'll go to red and let's go. So keep drawing our hexagons. Now I think that I'm drawing a lot of hexagons here. Obviously it's, as I mentioned, not an elegant way to tackle this, but I think that the process of actually doing this, you would hope actually helps a student kind of see what's going on, and that you know, even if they're out of ideas, like they're not really sure what to do, if in doubt, just draw what's going on, because sometimes that can be enough to give you the light bulb moments. So I'd be encouraging students to be giving something like this a go anyway, you know, even if they weren't sure it was going to lead anywhere. I mean, a brilliant student might just be able to notice some kind of pattern and come up with a formula, you know, just through innate ability. But, you know, for the rest of us, I think drawing up a diagram never hurts. It's always a good idea to try and get your head around what's going on with a problem. And this is definitely a you know, a challenging problem. It's by no means easy, which I guess makes sense if it's coming up on a scholarship exam for a fairly prestigious school. Yeah, it's no surprise that it's hard. So let's do our final count. So we're starting from 181. So let's keep going. 182, 183. 269, 270, 271. Okay. You hope you don't haven't missed any there. 271. Let's have a look. 271 minus 181 is 90. 90 minus 72, looking good. 18. So at this point, I mean, this is not a rigorous mathematical proof, but I would say in the context of an exam, you would say, hey, I've struck a pattern here. So let's just fill out the table in reverse, and maybe I'll use another color. So I can, against each n, I can write that the increase on the increase is going to be 18. And I'll just note all these down just for completeness. But the real kind of work happens once we start going, okay, well, if the increase on the increase is always going up by 18, well, what are the increases? And we'll get out our calculator. I'm assuming the students taking this test have calculators. If they don't, this question becomes even more difficult, although still it's adding double-digit numbers. So you'd hope you could still do it. It would just take you longer. But I'm just going to use my calculator to make sure I don't make any mistakes. So we'll go 90 plus 18 is 108 plus 18 126 plus 18, 144. Plus 18, 342. Alright, so if there are the increases, again, I'm just adding numbers now 3-digit numbers. So again, if you don't have a calculator, you got your work cut out for you, but we're going to have 271 plus 108 is 379. Then finally, plus 342, 3,421, and that is the answer that we've been working towards. So that's the final result that as a student you'd be answering for this question. Again, I don't really have any context to this question, like in terms of, you know, was it the last question of the test? How many questions were on the test? How much time was available? You know, is this approach that I've taken just far too time consuming given the constraints? I'm really not sure. You would also hope that if a student had the ability to take this approach, like to start drawing up the hexagons and to have the structure of a table like this, you would hope that even if they, say, ran out of time or made a mistake in their mathematics, even if they didn't get the exact correct number, you would hope that they'd still get some recognition, some marks or whatever the scholarship people reviewing this, however they work it out, whether it's through marks or just observing the way the student thinks, you'd hope that at least getting some part of the way through would be worth something, because this is definitely a challenging question. I think the approach I've taken, again, at the end of the day, it involved drawing, understanding enough to be able to draw a diagram, noticing a pattern, and doing some addition. Now, none of that's particularly sophisticated, but I think if a Year 6 student could pull that off, that would be pretty impressive. Now, I have no doubt in my mind that there are many other ways you could get to this number. By no means do I think this is the only way. Definitely not even the best way. I'm sure there's other elegant, efficient ways to tackle this. And if after watching this you have thought of something, please feel free to share in the comments. I'd be very interested to see what other ideas you may have about how to tackle this question. Keeping in mind that it's aimed at a Year 6 student level, so you might not want to throw out any particularly sophisticated techniques, although feel free, I'd still be interested, but you know, if you could come up with an even more simple and straightforward way that a Year 6 student could comprehend, that would be awesome. So hopefully you enjoyed watching that. Hopefully it all made sense. If you did find that explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions that other students are struggling with, please be sure to subscribe to my channel so that you can stay in the loop. Alright, tick boom.